A very good morning, good afternoon or good evening to all my dear students. Welcome back to my channel Enjoy Learning. Today I am going to tell you how to convert different expressions in terms of tan theta. But before beginning, let me remind you of two things. You have to be tension free and be focused, be attentive throughout the lecture. So let's begin. Now, why do you need to do such conversions? That means to convert different expressions in terms of tan theta. Because when you come across such type of questions, express the following in simplest form. What you need to do is, you have to remove this inverse function. I have also told you in the previous lectures this thing. Whenever you have to express a particular expression in the simplest form, what you need to do is to remove the inverse function and to get a simplified numerical value of that expression. So the only way to remove this tan inverse function is, you have studied in this property, tan inverse tan theta is equal to theta. So this is the only way where you can remove this inverse function and get a numerical or a definite value of this expression. This means that you have to replace this expression by tan theta. So this is what I am going to tell you, how to convert this expression in terms of tan theta. Let's see. Here is a very important trick. Whenever you get 1 minus cos x, we always attempt to remove this 1. Or whenever we get 1 plus cos x, we always attempt to remove this 1 in both the cases. Now how to remove it? Just keep in mind, when you get 1 minus cos x, then the formula of, you have to use the formula of cos 2x in place of this cos x. See, cos 2 theta is equal to, here you have to use 1 minus 2 sine square theta. This is the formula of cos 2 theta. So when you get 1 minus cos x, the formula of cos 2 theta that you have to use is this one. When you will put this expression in place of cos x, 1 will be removed. And simply, whenever you get 1 plus cos x, then the formula of cos 2 theta that you have to use is this one. 2 cos square theta minus 1. Then when you will put this expression, this value, 1 will be eliminated. So here you are seeing that here the angle is 2 theta and then it becomes just the half. 2 theta gives theta here. So similarly, here you have cos x. So when you will write the formula of cos 2 theta in place of this, then the angle that you will get here will be x by 2, half of this. See how to do it. 1 minus cos x, you have to use this formula. And whenever you get 1 minus cos x. So in place of cos x, we can use this formula, minus plus 2 sine square. Here you have x, so here it will be x by 2. See, here it was theta, so here it is theta. 2 theta, theta. Similarly, 1 plus cos x, so here, which formula you will use? This one. 2 cos square, 2 theta theta, so here you have x, it will be x by 2 minus 1. Now see, plus 1 minus 1, plus 1 minus 1. This is really very easy if you just remember these tricks. It is 2 sine square x by 2 upon 2 cos square x by 2. Now what do you get? Sin x by 2 upon cos x by 2. The root is removed. Now sin theta upon cos theta is tan theta. See, so simple. Now you can use this property. Tan inverse tan theta is equal to theta. So tan inverse tan x by 2 is equal to x by 2. See, what is the only thing that you need to do? You have to convert this expression in terms of tan theta, and then using this property you simplified this complicated question. Let's move on to the second. Here you have tan inverse 1 minus cos x upon sin x. Here also you have to express this in the simplest form. So here also you have to remove this inverse function, tan inverse. That means you have to express this expression in terms of tan theta. Let's see what we will do here. Here also you have 1 minus cos x. See, whenever you get 1 minus cos x, the formula of cos 2 theta that you have to put in place of cos x is this one. 1 minus 2 sin square theta. Cos x. 1. When this minus will change the form, change the signs. 2 sin square. Here you have x, so here it will be x by 2. Now in place of sin x, you can write, here also you have to use the formula of sin 2x. You know sin 2 theta is equal to 2 sin theta cos theta. Here you have 2 theta and here theta. Just the half of this. So sin x is 2 sin x by 2 cos x by 2. It's really very simple. Just keep in mind these two tricks. Now it is 2 sin square x by 2 upon 2 sin x by 2 cos x by 2. See, now sin x by 2 upon cos x by 2. You will get here also the same answer as in the previous one. Now sin theta upon cos theta is tan theta. So it is tan x by 2. Now using this property, tan inverse tan theta is equal to theta. You can write this is equal to x by 2. Now see, in place of 1 minus cos x, if you have got 1 plus cos x, then which formula you will put? This one in place of this cos x. Let me tell you. Here is just, you have to proceed just the same way. There is a single difference. Let me depict that difference. If you get this question, then also here the formula used is 1 plus cos x, see, so you will put this formula. 2 cos square x, so here it will be x by 2 minus 1 upon, in place of sin x, you will use the formula of sin 2 theta. So it is 2 sin x by 2 cos x by 2. Here it is x, so here it should be x by 2. Don't confuse in it. Don't do silly mistakes. This one is removed, plus 1 minus 1. Now see, here is just a bit difference. Cos square x by 2 is there. This and this. Here you are getting cos theta upon sin theta, which is cot theta. See, cos x by 2 upon sin x by 2. Here you are not getting tan theta. What is it? It is cot theta, that means cot x by 2. Now how to solve it? You should remember this property, that cot theta can be written as tan pi by 2 minus theta. See, cot theta can be written as tan pi by 2 minus theta. So just do it. Do this conversion. In place of cot x by 2, you can write tan of pi by 2 minus theta, that is x by 2. In place of cot x by 2, write tan pi by 2 minus x by 2. And now again using this property, tan inverse tan theta, this is the entire angle theta, you get theta, just pi by 2 minus x by 2. So these both are almost the same, just there is a bit difference in the last two steps. Keep this in mind, okay? Okay, so I hope these two methods of conversion are clear to you all, including the tricks that we have used here. Are trick 4 and trick 3 and trick 4. Okay. When you will get a question like this, tan inverse cos x minus sin x upon cos x plus sin x. Here also you have to express this function in the simplest form. So that means you have to remove this inverse function. So you have to express this expression in terms of tan theta. Then also you can remove this inverse function. So let's see what we do here. Here the first step that you have to do is to divide the numerator and the denominator by cos x. What you need to do? Dividing numerator and denominator by cos x. Let's see what we will get here. Cos x minus sin x upon cos x, dividing the numerator by cos x, and cos x plus sin x upon cos x, dividing the denominator by cos x. Here, cos x upon cos x is 1 minus sin x upon cos x is tan x upon cos x is again 1 plus sin x upon cos x is tan x. Keep in mind this first step, you have to divide numerator and denominator by cos x. Now let's move on to the second step. Here you can write in place of this 1 tan pi by 4, isn't it? Tan pi by 4 is 1. Whenever you get 1 along with this tan x, tan theta, what you need to do is to replace this one by tan pi by 4 and then see the magic. Here what you got. Tan in place of 1, again tan pi by 4 plus, can you write tan x as tan pi by 4 into tan x? Yes, you can. Why? Because tan pi by 4 is 1. There is no change in this. In place of tan x, you can write this tan pi by 4 into tan x. Now see, it is an identity for tan x minus y. See, tan x minus y is equal to tan x minus tan y upon 1 plus tan x tan y. See, here I have written this so that you should not make this mistake. You have to remove this 1 by tan pi by 4, but you don't have to remove this 1 by tan pi by 4. See, the identity is tan x minus y is tan x minus tan y upon 1 plus tan x tan y. So, don't remove this 1 by tan pi by 4. Write 1 in place of it. So see, it is tan pi by 4 minus tan x upon 1 plus tan pi by 4 tan x. So it is the identity for tan inverse tan pi by 4 minus x. See, tan pi by 4 minus tan x here. So it is tan x minus y tan pi by 4 minus x. See, it is so simple. You just need to keep two things in your mind. First step, divide numerator and denominator by cos x. Then the second step, replace the 1 in the numerator by tan pi by 4 and keep the 1 in the denominator as it is. Don't have to remove this one also by tan pi by 4. Then this is the identity you have to use here. Now tan inverse tan theta is theta. So it is pi by 4 minus x. Similarly, if you get just the reciprocal of this term, that means the question then will be this. Tan inverse cos x plus sin x. In the numerator, you have cos x plus sin x, and in the denominator, you have cos x minus sin x. Then also there is no need to panic. Just need to do the same step. Divide numerator and denominator by cos x. Then what will you get? There is just difference in sign. It is 1 plus tan x upon 1 minus tan x. Okay. Then again replace this 1 in numerator by tan pi by 4 plus tan x upon, keep this one here only, and write this tan x as tan pi by 4 into tan x, since tan pi by 4 is 1 only. So it will not change its value. So here, what is the difference? Here, there is only difference in sign. So here also, you have to use this property. Property for tan x plus y. See, tan x plus y is tan x plus tan y upon 1 minus tan x tan y. See, tan x plus tan y upon 1 minus tan x tan y. So here you have to use this property, tan x plus y. So you will get here tan inverse tan pi by 4 plus x, property of tan x plus y. Then also tan inverse, it is the entire angle. Don't get confused in it. It is tan inverse tan theta. So it is theta. This is the angle, whole angle, tan x plus y. Now let's take up the last one, which is this, tan inverse cos x upon 1 plus sin x. In these questions also, you have to replace this expression by tan of some angle, tan theta. Let's see what is the trick here. Here also you have to use the formula of cos 2 theta. But which one? You have to use here this formula. Cos 2 theta is equal to cos square theta minus sin square theta. This is also an identity. Can you remember? Here you have 2 theta and here theta. See, why are we using this property? In place of cos x, we will use this identity. So here you have x. So here you will put x by 2 minus sin square x by 2. And now, here, in place of 1 plus sin x, here you have 1 along with sin x. And in the previous questions, you were getting x in place along with cos x. See, 1 along with cos x, 1 along with cos x. Here it is another type of question. When you get 1 along with sin x, now how to eliminate this one? Just you must be knowing this identity. Just sin square theta plus cos square theta is equal to 1. Just use this one in place of 1, replacing this 1 by sin square theta. Now which angle you have to use? See, here you are getting x by 2 in the numerator. So here also you will use sin square x by 2 plus cos square x by 2. Now plus sin x. So in place of sin x, use the formula of sin 2x, sin 2 theta, which is 2 sin theta cos theta, plus 2 sin x by 2. Here it is x, so it is x by 2 cos x by 2. So see, this is the formula of sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2. This is the identity for a plus b whole square. A plus b whole square is equal to a square plus b square plus 2ab. See, a square plus b square plus 2ab. So it is equal to a plus b whole square. Tan inverse cos square x by 2 minus sin square x by 2 upon, place of this you can write a plus b whole square. Okay, a plus b whole square. A is here sin x by 2 and b is cos x by 2 whole square. Let's see what is the next step. It is really very easy. You will be surprised on getting the result. It is the formula. Here you can use identity. A square minus b square, cos square x by 2 minus sin square x by 2. A square minus b square is equal to a plus b, a minus b, 3. So what will you do here? Cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2 upon sin x by 2 plus cos x by 2 whole square. See, these two are identical, so these two get cancelled away. See what you are getting here. Cos x by 2 minus sin x by 2 upon sin x by 2 you just write here cos cos x by 2 plus sin x by 2. See, this is what we have learned in the previous question. Cos x minus sin x upon cos x plus sin x. Here it is cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2. Just the difference in the angle, which does not matter. So now proceed the same way. Divide numerator and denominator by cos x by 2 in this case, because here the angle is x by 2. Here the angle was cos x, so divided by cos x. So here it is x by 2, so you will divide numerator and denominator by cos x by 2 and then proceed the same way and get the answer. Okay, so I hope all the 4 tricks, all the 4 methods of conversion along with the tricks and the identities used in these questions are clear to you. Keep revising these identities and tricks and you will come out with flying colors. Subscribe my channel for the upcoming videos of other chapters. And yes, don't forget to like it and share my video among your friends. Thank you.